Scientists just discovered something on Jupiter's moon Europa that changes everything about where we should look for alien life. Europa has an ocean, more water than all of Earth's oceans combined, buried under miles of ice, in total darkness, no sunlight, bombarded by radiation. Researchers figured out how nutrients from the surface are reaching that ocean. Dense, salty ice is sinking, breaking off, falling through the ice shell, feeding whatever might be living down there. This isn't theoretical anymore. NASA's Europa Clipper is already on its way. $5 billion arrives in 2030. Because if life exists anywhere in our solar system besides Earth, it's probably there. Stay with me. Okay, quick backstory. Europa is one of Jupiter's 95 moons. Not the biggest, that's Ganymede. Not the closest, that's Io. But Europa? Europa is special. It's about the size of our moon, smaller than Earth. But here's the wild part. Europa has twice as much liquid water as Earth, all of it. Every ocean, every lake, every river we have. Europa has twice that amount. But it's not on the surface. The surface is frozen solid. Ice crust anywhere from 10 to 15 miles thick, maybe more. Underneath that ice, an ocean 60 miles deep, salty, liquid, dark, and at the very bottom, touching a rocky seafloor. To put that in perspective, the deepest point in Earth's oceans, the Mariana Trench, is 7 miles down. Europa's ocean, 60 miles deep, almost 10 times deeper. And scientists think something might be living there. So here's the problem scientists have been trying to solve for decades. Life needs nutrients, carbon, nitrogen, phosphorus, oxygen, the building blocks of biology. Europa's surface has those nutrients. Jupiter blasts Europa with intense radiation, way stronger than anything we get from the sun. That radiation breaks apart water, ice, and salt on the surface, creating oxidants, chemical compounds that can support life. But the ocean is miles below, under solid ice. How do those nutrients get down there? The ice shell moves side to side because of Jupiter's gravity pulling and squeezing Europa, but it doesn't sink. There's no convection, no mixing. The surface stays on the surface. The ocean stays below. Or so we thought. January 2025, a team at Washington State University published a study that changes everything. They figured out that salt changes the density of ice. Pure ice floats. But when radiation bombards Europa's surface, it creates salty ice. And salty ice is heavier, dense enough to sink through the surrounding pure ice. So nutrient-rich ice breaks off, detaches from the surface, and sinks slowly. Over thousands of years, all the way down to the ocean. They call it crustal delamination. It's a process we see on Earth, where dense crust breaks away and sinks into the mantle. Same concept, different material. When that ice finally reaches the ocean, it melts, dissolves, releases all those nutrients into the water. And if there's life down there, it can eat. Now let's talk about why this is such a big deal. On Earth, we have places where life exists with zero sunlight, hydrothermal vents, cracks in the ocean floor where hot water and minerals spew out. Around these vents, entire ecosystems, tube worms, shrimp, crabs, bacteria. None of them use photosynthesis. They eat chemicals, hydrogen, sulfur, methane. It's called chemosynthesis, making energy from chemistry instead of sunlight. And it works. Europa probably has hydrothermal vents. Its rocky core is heated by tidal forces, Jupiter's gravity squeezing and stretching the moon as it orbits. That creates friction, heat. And where there's heat and water meeting rock, you get vents. So Europa has the heat source. It has the liquid water. And now we know it has a way to get nutrients from the surface down to the ocean. That's 3 of the 4 ingredients for life: liquid water, chemical energy, nutrients. The 4th, time. And Europa's ocean has been stable for billions of years. If life started in that ocean even once, it's had 4 billion years to evolve, to adapt, to spread. That's longer than life has existed on Earth. This is where NASA comes in. The Europa Clipper mission launched in October 2024. $5 billion, the size of a basketball court when its solar panels are deployed. It's traveling 1.8 billion miles to Jupiter. Arrival, April 2030. Once there, it'll make 49 close flybys of Europa, some as low as 16 miles above the surface. Each flyby lasts only a few minutes, but it's gathering insane amounts of data. Here's what it's looking for. 1. Ocean conformation. Clipper has a magnetometer that'll measure Europa's magnetic field. If there's a salty ocean, it'll create a distinct magnetic signature that'll confirm the ocean's depth and salinity. 2. Ice thickness. Radar will penetrate the ice shell and measure how thick it is. If it's thinner in some spots, say 10 miles instead of 15, that's where a future lander might drill. 3. Plumes. Scientists think Europa might have water geysers, like Enceladus, Saturn's moon. If Clipper catches a plume erupting, it can fly through it and analyze the water directly. That's ocean water. Shooting into space. Free samples. 4. Surface composition. What's that reddish-brown stuff on Europa's surface? Is it salt? Organic molecules? Sulfur? The composition tells us what's in the ocean. Clipper won't look for life directly. It's not designed to. But it'll tell us if Europa is habitable, and if it is, the next mission will land, drill, and look for microbes. So what would life on Europa actually look like? Forget aliens with big eyes and spaceships. We're talking microbes, single-celled organisms, bacteria-sized, probably similar to what we have in Earth's deepest oceans, extremophiles, organisms that thrive in extreme conditions. They'd get energy from chemicals spewing out of hydrothermal vents, maybe from radioactive decay in the seafloor rocks. One study estimated Europa's ocean could support 1 septillion cells. That's a 1 with 24 zeros, the biomass of 1,000 blue whales. And if there are microbes, there could be bigger things eating them, not fish, not whales, but maybe multicellular life, something we've never seen before. The problem is, we can't see any of it. The ice is opaque. Radar can't penetrate that deep. We won't know what's there until we go there. And that's the next step. After Clipper, NASA's planning a lander mission. It would touch down, drill through the ice, lower a probe into the ocean. That mission is decades away, but it's coming. Because if we find life on Europa, even just bacteria, it changes everything. It means life isn't unique to Earth. It means life can start independently in completely different environments. It means the universe is probably full of it. Here's what gets me about Europa. Right now, as you're watching this, there's a moon orbiting Jupiter with more water than our entire planet. An ocean 60 miles deep, completely dark, potentially full of life. And we're on our way there, a spacecraft, right now, flying through space, crossing 1 billion miles to find out if we're alone. We'll get answers in 2030. That's 6 years. Some of you watching this will be in college. Some will have graduated. Some will have kids. And when Clipper arrives, when it starts sending back data, we'll know, is Europa habitable? Does its ocean have everything life needs? And if the answer is yes, the next question becomes, is anything living there? If you want more deep dives into space exploration and the hunt for alien life, hit subscribe. Drop a comment. Do you think Europa has life? What do you think we'll find in 2030? Let me know. Thanks for watching, and remember, the most exciting place to look for aliens isn't some distant star system. It's right here, in our solar system, under the ice, waiting.